our names are written in different ways. So if you think about, let's say, starting with the name in Hindi, if you talk about Rajiv as a common name, Rajiv could be written in at least 2 or 3 different ways in English. It could be spelled R-A-J-I-V, R-A-J-E-E-V, and so on. So for somebody who wrote his name as Rajiv Gupta in Hindi while providing information, right, to a company, it could show up in the database through different spellings. Now, addresses are even worse because we have virtually no standardization of how we write addresses in India. So again, this is a simple example of this guy Pramod Bhardwaj, number 85 Jayanagar 7th block, or it could be written 7th block Jayanagar 85, or it could be written 85 comma Jayanagar dash 7. Our own research lab for IBM in Delhi, there are 4 different ways in which we can write our address. 4 block C institutional area, or we could omit institutional area and so on. So, even though we have software, so there are multiple companies, all of these information management companies have software that helps you do this master data management, that helps you do this cleansing of data and figuring out these address differences and so on. And in fact, they also have rules often for different geographies. So in India, there could be a rule which says that the word marg is interchangeable with the word street or the word road. So we started with that software on the Indian address data, and we found that as we dealt with data from different sources, the accuracy of that software on Indian data was only close to about 20%. It was well over 95% accurate on address data in countries like the US and so on, but in India it was barely 20% accurate. So our team did a lot of work in novel work on this problem of data quality, of figuring out how to clean up all of these addresses into a canonical form. And in the process, one of the first things that it did was to develop a new way of organizing these rules in a more hierarchical manner. Because earlier the problem was you have kind of some India-specific rules. For instance, marg is interchangeable with road, so you can infer that one Parliament Street is the same as one Sansad Marg. However, when you start to add, when you say, oh, the accuracy is only about 20%, let me add more rules, people had no idea how the new rules interact with the old set of rules. So what this new framework did was, it made this whole, and this framework that we introduced was this ripple down rules framework, that this framework made it easier to, in a more systematic manner, add rules. We then came up with techniques to automatically discover these rules from the data. So can you analyze all of this data, and instead of a human formulating all of these rules, can you start to discover these rules automatically? And how do you estimate the accuracy? So this work has been again reported in a lot of top information management conferences, and we were able to improve the accuracy of address resolution to well over 75% by applying these techniques. It worked well over 75% until we got some data from a very large bank in India. So we have been using it in a number of real customer engagements in India. So when we got this data from a large bank in India, we got a lot of rural data, and suddenly our accuracy rates went below 50% again. Because in rural India, often the concept of street address doesn't exist, because the address might be behind that temple or opposite or whatever, close to that people ka ped and so on, and it becomes hard to uniquely identify the address. So we are still working on those some of those challenges, but the strength that we have is that we have access today to roughly data on roughly 60 million households. And if we compare our group with other groups that are working on a similar problem, we have at least an order of magnitude more data than any other group working on this problem. So it gives us an advantage in terms of the effectiveness of our techniques. So, so that was, yeah.
I have a question. This was happening because you were working on those data which were already available to you, right?
This was the data which was already captured in various databases.
It was already in the database.
Right.
Did you apply some kind of constraint, like when a user is coming with broadband connection, he already has a mobile phone and is also looking for a broadband connection. So is there any action taken at that side? Like if I'm applying for a broadband connection and I have a mobile phone, so when I'm applying for the broadband connection, I also mention my mobile phone. So automatically the mobile phone and the broadband gets connected here. Or if I'm applying for anything else, I again write down my mobile phone. So one mobile phone will make sure that my broadband number is there connected to it and any other services which I'm taking. So, you know, we can bypass, but this is.
Yeah, so you're making a very good observation. And if you look at the UID project, Unique ID project that Nanda Nilekani is using,
right,
that is pretty much an attempt, right, to provide a single identification, right, to all of the citizens of the country. So what you're talking about is absolutely the right way to go, right?
Yeah, but the problem here
is in the real world, you always need to deal with legacy.
Exactly. I was coming to this.
Right.
So this is a case where we know the problem, so we try to be proactive. Now, the reactive problem, like we already have database. Okay. So there you are trying to correlate the addresses.
Right.
Okay. So what other ways you have tried other than correlating the addresses, right? Set of data you have and you are correlating it, right? So other than the addresses, matching of addresses, what other techniques you thought about? I mean, I'm just asking, like, you must have tried many more techniques before zeroing down to this.
Right. So this particular problem doesn't arise only in the context of addresses. It also arises in the context of other kind of data, for instance, names, even product names. So if you take, let's say, something like arhar dal. Arhar dal is known by all kinds of different names, tur dal, and there could be other languages and so on. So even in product names and so on, there are these kinds of issues that come up. Then when you're trying to unify all of this information, do some kind of master data management, you have to come up with the canonical representation. So it doesn't arise only in the context of addresses, it is a fairly general problem. What we have done is, because we were dealing with the single view of the customer problem, where the defining kind of methodology is to go by the person's name and address. So therefore we were initially looking at it just from the name and address perspective. But as I mentioned, this is a broader problem. So we are also looking at other aspects of it, like product names and so on, and doing cleansing. So the overall area is known as master data management. So again, we are applying various techniques to do more effective master data management. So let me give you kind of just maybe one or two examples. So there is again a lot of work being done on what I would call building these smarter planet systems. So let me talk about some recent work that we have begun in the healthcare, which we are also now trying to apply in the Indian context together with a leading hospital chain. We are talking to them. So on the healthcare, one very promising direction is that more and more in the Western world, you have patients' medical history is becoming available in electronic form. So electronic health records are becoming common. And even in India, if you look at the major hospital chains, they are capturing more and more of the patient information in electronic form. Now, there's an opportunity. If you start to do analytics over all of this